Good afternoon, Varsha. So today we will study about the traveling salesman problem. So traveling salesman problem is similar to your assignment problem. Here the changes is nothing but whatever the man salesman is taking the number of cities, his intention is to visit all the cities in a minimum number of times. Okay, he want to minimize his time to cover all the cities. So here to visit the cities, for example, he want to visit two cities. There is a choice to visit B city or no, B city or A city. Okay, two possibilities to visit four cities. We have three possibilities. Okay, so like that, whatever the salesman is there, how many cities he want to visit it in a minimum number of times, that value we are going to calculate here. So that kind of problems we can call it as a traveling salesman problem. In the sense, in a minimum number of time period, he has to complete all the cities. Okay. So mathematical formulation is nothing but you will be having one objective function in the form of minimize. Our intention is to minimize the time period. So objective function is z equal to summation I equal to 1 to n and j equal to 1 to n cij xij. Okay. So ith person, ith salesman, he want to visit for the jth city. If you are having n cities, in the sense he will be having n minus 1 possible routes. Okay. So that value we are going to calculate here. So subjected to the constraints, he will be having different conditions to travel for different cities. He will be having certain conditions. It may be in the form of weather forecasting or traveling facility. So different kinds of problems or different kinds of conditions will be having. So in case of traveling salesman problem, here the condition is nothing but that salesman which from which city he is starting his sale, so to the same city he does not return back without traveling to all the cities. For example, his intention is to cover six cities in the sense. If he start from A city, he doesn't come back from B city to A city. He has to cover all the six cities and again come back to same city. This is the condition. And second condition is he does not go for the same city twice. Okay. So without completing all the cities, he does not come to same cities to do the twice position. Okay, these are the condition for the traveling salesman. Okay, so we'll take this in the form of a problem now. A traveling salesman visits five cities. He wishes to start from a particular cities, visiting the each city once, okay, and then returns to his starting point. The cost going from first city to other city. And now we have to shown below whatever the cost is there to travel from A city to A city, A city to B city, and A city to C city. All these cost it is given in this matrix, and we have to find the total cost and also the transportation, the way and the route we have to calculate, and also we have to calculate the total cost to complete all the city. How much cost he is taking and what is the route, that value we have to calculate it. Okay, so this is the problem they have given. From this city, ABCD city to ABCD city, he is traveling. Now, first thing is you have to do the row reduction. Row reduction in the sense, in the last class, how we have done in the same manner. In each row, you have to calculate the minimum value and you have to subtract it. So, in the first row, the minimum value is 1. So, you have to subtract this row by 1. In the second row, the minimum value is 2. You have to subtract the second row by 2. And similarly, in the third row, the minimum value is 4. You have to subtract, and in the fourth row the minimum value is 4, and the fifth row minimum value is 1. You have to subtract the respective rows by the minimum values present in that row. So you will get the row reduction matrix like this. Okay, so here in the first row, as I told, 1 is the minimum value, so it is 2 minus 1, so it is 1. 5 minus 1, it is 4. 7 minus 1, it is 6. 1 minus 1, it is 0. Similarly other rows. So after completing the row reduction, now we go for the column reduction. Column reduction in the sense, in each column you have to select the minimum value and you have to subtract it. So in the first column, what do you have to do? In the first column, the minimum value you can select it, or else one more step you can do. After this step, you can select the number of rows, number of zeros. How many zeros are there? That zero you have to shade it and delete the column. Here, the first row, so one zero is there, allocate it. Okay, and since we have selected this zero, and delete this column. Okay, and in the second row, one more zero is there, so already we have deleted here. By allocating this 0, we have deleted. So leave it. In the second row, since it is deleted, we do not to consider. Okay. And in the third row it containing 1 0 here. Okay. Make it as box and delete this column. So D column is deleted. Then go for the D row. So it containing 0. So delete this column. And E, it containing 1 0, make it as box and delete this column. So you have deleted all the columns now. Okay. And you have allocated the values also. Now you have to see the number of lines. Number of lines here 1, 2, 3, 4, 5. So number of lines is 5 and order of this matrix is also equal to 5. So when order of the matrix and number of lines, when it is equal in the sense optimality is reached, and this is true for assignment problem. Now you have to see the way, the route you have to select now. A salesman, he has started from the city A and he has reached to E city. And for the E city, you can see from E city to A city. So he has traveled E twice. First he went to A to E and E to A he is coming back to original. But he has not covered B, C, D. So that shows that we have not reached the optimality. Okay. So this is not the correct optimality. So we have to change our route now. So how to change the route? That can be done in different way. So what you have to do is, in this matrix, you have to see the first row. Select the next greatest number to 0. 0 ಆದ ತಕ್ಷಣ next greater value ಯಾವುದಲ್ಲ ಅದನ್ನು select ಮಾಡ್ಕೋಬೇಕು. That value is nothing but 1. Okay. So you have to select this as 1. 1 as a greatest element after this 0. So allocate that 1, not for this 0. Okay, I repeat once again. So optimality is failing here because he is coming from A city to E city and E city to A city. Okay, E city to A city. So that's why optimality is not reaching here. The condition is failing for the travel salesman problem. So because he has not covered B, C, D. So for that, the next step is nothing but you have to select the greater value next to 0. That value is nothing but 1. So allocate that 1. And if you are having any 0 in that row, make it as cross mark. Okay. So I will show that step now. Okay. So that explanation is here in this paragraph. Now, since you have allocated 1 here, so 1 is allocated, then delete this column. So 1 is allocated in the sense you can delete this column. Now go for the second row. If you are having only 1 0, then delete that column. Okay, I will take this matrix. You can see now. Just a minute, I will share the screen.